Thank you. Thank you and good afternoon, everybody. I'll try to share my presentation. Are you able to see my slides?
Yes, you make it presentation mode.
Yeah.
Yes, okay.
Thank you. I will be presenting NCMRWF contribution to RHYMES program. Before that, I will be introducing NCMRWF and our core capabilities. NCMRWF is a center of excellence in weather and climate modeling under Ministry of Earth Science, Government of India. Our mission is to continuously develop advanced NWP system for India through R&D and maintain highest level of technical expertise. So our core capabilities include mainly the seamless prediction system based on unified model. This includes global model forecast for 10 days lead time, and all India short range forecast for 3 days, all India domain, and coupled system for season to season forecast based on ensemble techniques for a month of for extended prediction and for 3 months for season forecast, and data simulation for atmosphere, oceans, sea ice and land. Also, we have developed the reanalysis products for India and with a global scope. And NCMRWF is the only center in the it's running an end-to-end NWP workflow, starting with the reception of terrestrial and satellite observations through global telecommunication systems and directly receiving the data, and data assimilation using advanced techniques and hybrid data assimilation, and then running our seamless prediction system with a resolution ranging from 330 to 60 kilometer resolutions, and then post-processing the data, then issue the model forecast to various agencies, evaluation and forecast. You can see the ensemble method shown on the middle right. So, and see the products of PM 2.5 verification with the observation. And this is our seamless prediction system, where we have a Delhi fog model, which is 230 meter resolution, which is run for 48 hours only for winter or Delhi, and then another domain 1.5 kilometer over North India is 48 hour forecast, and 4 kilometer regional model with a 72 hour forecast, which includes even the BIMSTEC countries, which covers the BIMSTEC countries, and global model at 10 to 12 kilometer, and the ensemble prediction system, global ensemble prediction system at same resolution with the 23 members. Then coupled global coupled model at 60 kilometer, which is run for a 1 month lead time. And to say talk about the capability of our modeling system, the recent case of the Wayanad landslide event was predicted some indications of extreme event even up to day 5. You can see the top left is observation 25 kilometer resolution showing some pink color where models are showing pink and red color regions. This 5 days in advance, and this is a coupled model for medium range NWP is compared against previous last time with atmosphere only model, and the mean bias is reduced over the ocean due to the coupling. And another thing is that for extreme events, the coupled model seems performance is better in the longer lead time compared to the uncoupled model in the location of the extreme event or CNK. And coming to the regional model at 4 kilometer resolution, we have it is supposed to explicitly resolve convection. So convection parameters is off in here, and we have very advanced microphysics and cloud scheme, and you can see the domain is extended to cover the BIMSTEC region, and you can see the Delhi model domain and Amarnath model domain, which is over 1.5 kilometer over Himalayas, which is we are run for the Amarnath period. So this is one of the products from the regional model where you can see anywhere any signage of any extreme event in terms of lighting flash cone, wind gust maxima, dust optical depth, and dust concentration. And when it's come to sub-kilometer modeling, we have Delhi DMCOM, which is having all the component processes involved, like aerosol and chemistry, then urban morphology, which results when the building and street canyons, then widespread irrigation, which is widespread in our North Indian domain. And we are including the aerosol emission inventories, aerosol emission inventories also. And biomass planning is included through global fire assimilation system. And the products is the visibility, pollution, PM 2.5, and near surface parameters. And this is the performance of DMCOM during the 2024-25, where we have very good performance at 10, PM10, whereas PM 2.5 is showing some bias due to mostly because of the cloud lowering fog situation. And this is one day verification of visibility, temperature, and relative humidity, and then the skill score, skill for the 30-meter model. And we are also running ensemble prediction system. You can see this STAM 22 members, which will give an uncertainty in our determinants model as well as probability type of forecast. And the NCMRWF coupled model already we are running at a first resolution, 15 days deterministic model and extent range that is for 1 month period and season for 3 months. And we will be immediately going for 10 kilometer coupled model and a regional model that is 4 kilometer regional coupled model. And this is the one product of the extent range prediction for 4 successive weeks, which are anomalies showing precipitation anomalies. And we have several sectors applications, so wind energy, solar, many other sectors are there. And we have recently commissioned a new SPC by the Honorable Prime Minister with 7.47 petaflop at 2,115 knots, which will advance our activities and research and operational activities. And coming to the RIMES activities at NCMRWF, we are having extent range products. We are providing extent range product RIMES countries on rainfall, temperature, minimum, maximum winds. And we are having weekly discussions in South Asian Hydromet Forum, Forecasters Forum training, and we have given training for RIMES scientists. And RIMES is running BART models that are using it in our MIHR system, and we are doing verification of extreme rainfall events for using Sierra techniques. And this is the weekly MAP discussion forum for which is led by Dr. Mohan and Dr. Ankur. And which will discuss weekly forecast as well as once in a month seasonal forecast also. And these are the different parameters we are providing for our coupled model, from our coupled model. Then this is one of the example of precipitation anomaly and precipitation for the weekly anomalies. And this is another example for the tropical cyclone ensemble strike probability as well as the meteogram. Then this is the drought product, which will show, which is from product from July 7, 2023, which is showing on the left side top left, we have the observed standard rainfall anomaly, which is quite well reflected in the 1 week, 3 weeks, 2 weeks, 3 weeks, and 4 weeks in projection. And we are running a WARF model, which is this is one of the examples of. Then we have conducted training for RIME scientists during 23 to 27 September 2024 for different on which is they are trained on different techniques of bias correction, verification using MET and MET plus, then process oriented diagnostics, and ensemble data for extreme rainfall verification. And so what we can provide further is our medium range forecast products from global model as well as regional model, the historical products for rainfall, dust, lightning, dust concentration, and coupled model also. And then so future we have looking for advanced in observational ecosystem and data simulation, seamless earth system modeling, and hybrid modeling with the AIF ML technique. And we are going for the next generation modeling system and advanced in science and technology, so building and cloud usage of cloud and product for diverse applications and capacity building and AIM. So here this is my last slide. Thank you.
Thank you, Dr. Sajid Mohan.